normally the mean it's not there. So you will be given the sample mean, and the sample mean is the best estimate for your population mean. So even though the question asks you about the population mean and you are not given the population mean, but you can use your sample mean to estimate your population mean. Okay. And then we have confidence interval. So under confidence interval, we have population mean, where your sigma is known, and in this case, you have to use the distribution, or your sigma or your population standard deviation is unknown. In this case, you can use t distribution. And if you look at the formula, they are looking the same, right? The difference is just whether it's z or t distribution. And then you're going to have proportion under the confidence interval, sample size, and finite population adjustment. That's it. Okay, so you are having like 1, 2, 3, 4, 5, like 5 formulas. So this chapter shouldn't be hard. Okay, and it is very straightforward. So let's look at the question. Okay, you should be fine. Okay, so this is your question, right? Okay, so Amina got a new car as a gift for her birthday. Wow, so her parents must be very rich, right? So that's why she got a car for her birthday. She kept careful records of the fuel efficiency of her car because somehow it is her present. Okay, after the first 9 times she filled up the tank. So, okay, what else? She discovered that the mean was 23.4 miles per gallon with the sample standard deviations of 0.9, and then using 95% confidence interval. How many times should she fill her tanks to get a margins of error below 0.1 mpg? Okay, now tell me the information. What do you have? So the first information that you saw is the mean was 23.4 mpg. So what is this 23.4? What should I write here?
Mean.
X bar.
S bar.
Yeah. So x bar equals to 23.4. Next, what else? You're gonna have your sample standard deviation. So what should I write?
S.
S equals to 0.9. And next, you're gonna have margins of error, which is 0.1. So what is the confidence interval? Equals to 95%. This is percent. Okay, now the question asks how many times or whatever. When we talk about how many numbers, what is that? Should we use confidence interval formula? Should we use sample size formula? When you talk about how many number?
Sample size.
Sample size.
Sample size. You are asking about the number, right? So whenever you look at the question asked about how many, so it refers to your sample size. Even though they will not ask you how many sample, how many number. So it definitely tell you that you have to use the sample size. Okay, now, should we use population mean or population proportion? Because you have two formulas under sample size. So you should know which formula should you use. The first one or the second?
Mean. Population.
Population,
Mean.
proportion.
Mean.
Okay, the mean, okay. If you look at this, what we call information here, in order for you to find the proportion, if you want to use the formula of proportion, you should get the information on proportion, which is x and n. So you need to be given x as well as the n. So here you don't have the x and you don't have the n. So definitely you cannot use the proportion. So you only have population mean. That's it. Okay. So that's how you want to look at it. Just to differentiate which formula should you use. Okay, now, so what is the formula? I forgot. So the formula is
N equals to Z.
And then, okay. This is the formula, right? Okay, so let me close this. Okay, so your Z. Okay, basically you have to convert your confidence interval into the Z value. So 95%, how do you want to convert it into the Z value? Tell me.
1.96.
1.96.
Okay, okay, 1.96. Wow. Everyone knows how to convert it, or should I show the step one by one? Or
Divide by
it's
2.
fine. Okay, what is divided by 2? 0 divided by 2.
95. Divide by 2.
95 change it to decimal. After that, divide 2.
0.95 divide with 2. What should you divide by 2? This is my question. Why?
Because we have
The Z table
two sides of the graph.
Because
unit of
you
half.
draw a diagram, you have two tail. So you have to make sure that one is given to this tail and another one is given to this tail. So 2 is refers to two tail. Means that whenever you get the value, you divide with 2, showing that you are given equally to these two tail. So 0. This is 995 divided by 2. What will you get? Point. Did you even divide by 2?
4, 7,
4, 7,
5, I think.
5. Okay, so now is this the Z value?
No.
No,
So we have to refer to the Z table. So this is your Z table. We call it area under the normal curve. You can see the Z is somewhere here, if you can see my cursor. So 0.475, it is given here on top of it. You don't really have to look at inside the table. But if you want to look at inside the table, you can just find for 0.4750. Where is it? 0.475, this one, 0.4750, which is 1.9, and then when you look up, 1.96. That is the Z value, which is 1.96. So the Z value, let me rewrite here, Z equals to 1.96 multiplied with sigma. So this is sigma, this is not 6, okay? So what is the value of sigma? Oh, well, doesn't matter. Because the formula says it is the sample standard deviation, but the formula use sigma. Well, this is just the same as our sample standard deviation, which is multiplied with 0.9 over, we have a very long over E. What is your E? 0.1. Is that all? You're gonna have squared here. Given all this information, you should get the value of, what is it?
311.17.
311.17. Okay. It's up to you. You can stop at, well, whatever decimal point. Is that the final answer? This is 3. Why the 3 doesn't look like 3? Is this the final answer?
No.
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 Okay. When we talk about number, you don't have, I have 311.17 chocolates. No. You have to round it up, become 3, 1.
2.
So this is the final answer for the number. Okay, you have to round it up into a whole number. Even though in maths, if you want to round it up, 311.1 will become 311. But in statistics, we want to be conservative, so you have to make it a bigger number. So 312. Okay. Any question regarding this question? So far, so good?
Yes.
Okay.
Yes, I have.
Okay. If you didn't get it right, please let me know why it is so that we can discuss together to make sure that everyone is clear about the issue. Okay. So, give me like 1 second. I have to check my kitchen. Okay, done. I'm cooking porridge for myself because I'm not feeling well today. Okay, the second question, I don't know where is it. Should be this one. Mm. Yeah, this should be the second question, right? Okay, let me open a new blank sheet. This one. Okay, so you plan to conduct a survey to find what proportion, okay, this given that of the workforce has two or more jobs. Well, somehow, okay, it is mentioned proportion, doesn't matter. You decide on the 95% confidence interval and a margins of error 2%. Okay, so since the data are given, let's just list down everything. So your confidence interval equals to 95%. So later on, you have to convert this confidence interval. The margins of error, your E equals to 2%. What else? A pilot survey revealed that 5 of the 50 sampled. So what is that 5? Huh?
P.
5 is P?
N. Small n.
5 is X. So 5 is actually your X. And 50 is actually your N. Okay?
Oh.
You have like you survey 50 people and then 5 out of that 50 um, um, hold 2 or more jobs. Okay, so this 5 refers to your X. How many? So the question was about how many. So you have to refer to the sample size formula. And in this case, you are given X and N. So you can compute the pi or the P, the proportion. Okay, so what is the proportion? X over N, right? So let me just write the formula. Doesn't look good. Okay, so the formula for pi is X over N. This is proportion as well. So it equals to 5 over 50. So what will you get? 5 over 50? Do you have your calculator with you? You should get
0.1.
0.1.
0.1. So what is the formula to compute proportion for sample size? Anyone? What is the formula? Ting, 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 ting. So n equals to your pi or your p multiplied with 1 minus pi multiplied with z over e. This is e squared. Okay, now close the formula. We already got the information. Okay, so, well, you have to convert this 95%. So what will you get? We have converted it before, right?
1.96.
Yes. So I have shown the method before, so you should get 1.96 from the z table. Okay. So your pi here is 0.1. So this p is also equals to pi, refers to proportion. So 0.1. So 1 minus 0.1 this is 0.1 multiply with your z. Your z is 1.96 over e. What is e? 2%, which is 0.02, and then put a bracket squared. So given all this information, you should get the value of, what is it? 864.36. Is this the final answer for number? You have to round it up into a whole number, so you should get 865. So this is the final answer for how many, for a sample size, for a number. Okay, so any question? It is very straightforward. Everything is there. So you just plug in the number into the formula. So any question?
Ma'am, can you tell me how did you find the critical value C1? Because I got 1.664. That's why my whole answer became wrong.
CI is not critical value, right?
No, sorry.
What is it, everyone? What is CI?
Confidence interval.
Confidence interval.
Confidence interval. Okay. Okay. Well, we have
Correct.
explained this before. It's okay. So if you look at here, you decide on the 95% confidence interval. Don't worry, we will look at it together. So confidence interval, you can write the whole thing, but I'm just a bit lazy to save the time. So CI is confidence interval, which is 95%. Okay. So you have to convert it into Z, right? Okay, so what you can do is that, tell me, you have, what is it?
95
0.95
Yeah.
and then
Divide by
divided by
2.
2
by
divided with 2. Why with 2?
because have two tails.
Because you have to
easy
tell
table have
4.
to tell.
You have to tell, and then what will you get? 0.475.
475.
Okay, so let's look at the Z table. This is Z table, area under the normal curve. The Z is somewhere on top on the left side. Okay, so where is it? 0.475. I will look at here, 0.475, the value is 1.96, but this is not how you want to find it, because later on you may get a different value. So just look at the area under the curve. Inside the table, 0.475. Okay, make it bigger. So let's find it together. Where is 0.4? This is 0.2. This is 0.47. 0.475. So this is if you can see my cursor, 0.475. So what you can do is you look at to your left side, 1.9, and then you have to look up 1.96. That is the value of 95% confidence interval. So you will get 1.96. Okay. This is if let's say it is Z value. If let's say you use T, you will have a different method. Okay. Any other question?
Madam,
Mm-hmm.
is it okay if we round up to 864 instead of 865?
It is not okay. Why?
Okay.
Okay. Why is that? Okay. As I mentioned to you in mathematics, if let's say okay, maybe I will just write here 864.36, because this is lesser than 5, right? So you will round it up into 864. But math and stats is a different knowledge. So in statistics, we think that if we round it up become 864. So you miss this. You didn't take into account this value. So we don't want everyone being excluded. So we want to make sure that everyone should be included in our estimation. So we take it into our estimation. So we make it conservative 864, 865. So we didn't exclude this. We still include them, even though it is not that many, but we want to make sure that they are included into our estimation. Okay. In maths, they are very lenient, so they don't really worry about this small number of people. But instead, we want to make sure everything should be included in our estimation. So we round it up into 865. In the textbook, they said that we have to be conservative by taking a larger value compared to a smaller value. Okay, anything else?
Madam, if the last part is we making a mistake, is it like we have to minus 0.5?
I'll see how to decide. Well, you know that this is like 2 marks, right? So maybe, yeah, instead of getting full mark, you may get 1.5 marks. Well, that's fine, right? 0.5 is a very little mark. If let's say you got 100%, just 99.5 is good enough. Okay. So anything else? Anything else? Is it clear?
Clear.
That's why you have this quiz, so that you know how to get a better marks. because in your test later on, the mark is larger than your quiz. Your quiz, you may miss, if you make any mistake, you may miss just 0.5, 0.5. That's good. But in the test, you may miss 2 marks. So if you know now, so you can reduce the problems of making mistake later on. Okay. So, okay, let's go to the next question. Open a new one. Oh, okay, what is that? Oh, so many. Section 1. Okay. Okay, so a survey. So let's do this together. Make sure that you have your calculator with you. Okay. So a survey of 50 workers. What is this 50? Tell me. What?
And
Okay, cool. Who were laid off during the COVID-19 revealed that it took a means of 26 weeks for them to find another job. So what is this 26? Your 26. Okay, so why this is X bar, not mu? Because the question said a survey. So when you talk about a survey, definitely you will collect your sample. And the mean should be a sample mean, which is X bar. Okay. What else? The standard deviation. So this standard deviation is what?
S.
S. So the standard deviation should be a sample standard deviation, which is 6.2. Using 95% confidence interval. So this is our confidence interval equals to 95%. Is it reasonable that the population mean is 28 weeks? Okay. So this question is asking about population mean. Okay, let's look at the formula. Which formula should you use? Let me put it here. So you have the question asks about the population mean, right? So population mean. Here you have to choose. Should you take the first one, Z distribution or T distribution? Which one?
T distribution.
T distribution.
Why Z? Is it Z or T?
T.
T.
T. Table. Right. So T distribution. Why T? Because
Your sigma unknown.
yeah, your sigma is unknown. Your population standard deviation is not given. Here, the standard deviation is a sample. Okay, the standard deviation given here is a sample standard deviation, not a population standard deviation. So you have to use a T distribution. So what is the formula? Let me write it here so that we can just apply it. So X bar plus minus T and multiply with S over square root of N. Okay. So now, before we apply this formula, can you convert this confidence interval into the T value? Anyone? Should we use this area under the normal curve table?
No.
No.
Which table? This table. Let me make it smaller so that you can see this. So we have to use the T distribution table. Okay, so you have this whole thing. What is the the CI? 95%. Okay, remember that 95%, make it bigger. Okay. So you have 95%. Can you see confidence interval, confidence interval? So you have 95 here, 95 here. So how to look at it? There are so many numbers, 2 tables here. So how to find it?
Find the DF.
So, okay, so which DF? Number 1, number whatever. How?
50
minus
minus
1.
1.
50 minus 1.
So the
49.
DF, this is DF, has a formula of N minus 1. So what is your N? Your N is 50. So 50 minus 1, you have the value of 49. So find this 49 under the DF. Okay, so if you scroll down, you start from 1 until, well, 35. So you have to go to the next table, which is 49, right? So we have this 49 here, right? If you can see my cursor, where is the cursor? Okay, make your screen larger. Okay, so 49, and then you want to see the 95%. So when you scroll down, the value of the t is 2.010. Can you see that? Any question? Is it clear? So from this 49,
Yeah, madam.
you move to the right, and then you look up, which is 95, you should get 2.010. So your t is 2.010. Now everything is here, just plug it into the formula. Your x bar is it 26? Is it 26? Oh, my handwriting is impossible. Yes. So x bar is 26 plus minus t. What is the value of t? 2.01. And then s is, what is the s? 6.2 over square root of n, 50. So given all this, you should get the value of what? 24.24, because there are plus and minus here, and you are talking about interval, so you should get two value. And second one is 27.76. Okay, so normally when you have plus and minus, you have to start with minus, because your interval should start from the smallest to the largest. Some people will take plus and then get minus. So you will start with bigger and smaller. So interval will start with smaller number to the larger number. So do the minus first and then the plus. So is this the ends of the answer? Does it answer the question now?
Yeah.
Not yet. The question asks, is it reasonable that the population mean is 28 weeks? So the question asks, is it reasonable when you said that the interval is 28 weeks? Yes or no?
No.
Why?
Uh, not contained in the answer.
Because 28 is
Not
outside.
within under the range.
Yes, it is not within the interval range. Or if we can say that 28 is outside the interval. Okay, so your interval start from 24.24 until 27.76. That's why I said you shouldn't round it up. You shouldn't round it up. If you round 27, you will get 28. But in statistic, decimal point is very important. So this 28 is not within our interval, our confidence interval. So the answer is no. If let's say the question change, is it reasonable that the population mean is 25 weeks? So what is the answer?
Yes.
Yes.
Yes,
In the range.
it is within the range, right? So any question regarding this? No, it's clear, right? So some people will stop until here. This is not the answer. So you are not answering the question. So you have to say yes or no. And then you have to explain why, because it is not in the interval, or it is outside, or it is inside, or whatever. Okay, you have to answer the question. So this is the question for section 1. And let me open a new one. Oh, I don't have any space. Painting, please. Okay. So let's open the last question. Okay. So now I hope that you can see my question. If you couldn't, then make your screen larger. Kuliah of Economics and Management Sciences randomly test its students. Okay, with apostrophe, about the university's rules and regulation. Last semester, in the 400 random tests conducted. So what is that 400? Tell me.
X.
X,
N.
N. Is it small n or capital N?
Small n.
Okay.
Capital.
Okay. So small n refers to sample. Capital refers to population. So you should know that. Okay. Do you think that populations of IIUM is 400? Well, it is too small. Okay,
No.
doesn't matter. But if you look at this question, last semester in the 400 random test, so you collect a sample randomly, right? You cannot do random sample if let's say you want to take the whole population. You will select a sample randomly from the population. So it is a sample. Okay, so random normally applies to the sample. You don't apply to population. If you just survey the whole population, you will not use random sampling method. You will just say, I survey the whole population. Yeah, but now you are taking 400 out of whatever number of the population. So 400 here is a random sampling method. So if you can see, let me write here, random sampling method. So it is sample. So random refers to a sample method that you use. Okay. So make sure that you know, because if 400 is a population, you have to use a different formula, which is finite population adjustment. So you have to be clear whether it is capital N or it is small n. Okay. So this is small n because you sample it randomly. Okay. So which is 400. The next 14 students. So out of this 400 n, 14 students failed the test. What is this 14?
X.
X. So do you know what kind of question is this?
Proportion.
Yes, you have the X, you have the N. So it should tell you straight away, well, should be proportion. So even though you cannot see the proportion words, this should be proportion. Using the 99% confidence interval, so let me just write it here. Confidence interval is 99%. Will it be reasonable to conclude that 5% of the students cannot pass the test? So now, so this is about proportion, right? So let me open the formula, the overview. Where's the proportion? This is population mean population proportion. So let me just write the formula first so that you can see the whole thing. So proportion plus minus z square proportion 1 minus p over n. Okay, done. So now, you only have n, x, and confidence interval. Okay, before that, how to change this confidence interval 99% into the z value? You should know, right? Tell me.
0.99 divided by 2.
0.99 divided with 2. So what will you get?
0.495.
95.
0.4995. Really?
95.
95.
Point,
1 9 only.
0.95. Okay. 0.9.
Yes.
Okay. Okay. And then, can I just trust you? You know how to look at it from the table, or should we look at the table together? Okay. Let's look at it together. It's easy. So this is the T table. We shouldn't look at it. We should look at the Z table. What is the value? 0.495. I'll make it bigger so that we all can see it. 0.495. 0.49, 0.4449299694 49494951. So which one is the closest?
Bigger.
5-1.
So what you can do, you have to take 0.495 minus these two value. So which one will give you the closest guess?
Both.
Both. Yes. So in this case, since these two value will give you the same distance, the same gaps. So according to the statistic, you have to, normally if let's say one of the two will give you the smallest, then take the smallest. But if let's say the two value will give you the same gaps, take the largest. Means that to be conservative, we will take the bigger value, which is this one. So the Z is actually 2.5, and then when you look up, you will get 8. 2.58. Okay, so let me write it here. So you should get the value 2.58. Okay, so you have to also compute the P, right? So how to compute the P of pi?
X divided by N.
X divided by N. Your X is 14, and then divided by N, your 400. So this should give you the value of 0.035. Now, everything is here. Just apply the formula. Okay, where should I write it? Yeah. So your P is 0.035, and then plus minus your Z. Z is here, 2.58, and then multiply with the square root of P. P 0.035. So 1 minus your P 0.035 divided with your N, 400. Okay, so given all this information, you should start with the small minus and then plus. You should get the value of 0.0113. This is the minus one, and 0.0587. Okay, so is this the final answer?
No.
The question asks, will it be reasonable to conclude that 5% of the students cannot pass the test? So they make it percent. So let's make it percent as well for our answer. So 1, 2, so you have, this is 1.13%. And the second one is 1, 2, this is 5.87%. So 5%, is it under the interval?
Yes.
Okay, the answer is yes. If let's say the question asks you, how about 1%?
Not reasonable.
It is not reasonable because our interval starts with 1.13, not 1%. 1% is out of the interval. Okay, so got it? Okay, any question? So any question before we end our class? Oh, let me end the recording. Okay, so anything you want to ask?